Hello guys, I'm back with another question. This is fractional knapsack. Now there are two types of basic problem in knapsack. One is the 0 1 knapsack and the other one is a fractional knapsack. This knapsack is a bag, actually a bag. You can see the word sack here. It's a sack. So fractional means you are allowed to put things in fraction also, like you don't need to take the item whole as a whole. You are allowed to put a fraction as well. And in 0 1 knapsack you are allowed only to either to take the item or skip it, not take it absolutely. Let's have a look what all is given in the question regarding the coding part. So we are given with two arrays, value and weight. These are represented by value array and the weight array here, right? And we are also given a capacity that is the maximum weight of the sack that the sack can hold. So we are bound with the foundation of this capacity here, right? Now what is our goal? What do we have to return? We are allowed to break the items into fractions as discussed earlier. Return the maximum value as double rounded to 6 decimals. Uh, we need to we need to return the maximum value that we can attain uh, in B with the foundation in the limits of the capacity only. So the maximum value has to be returned.
Now, if you closely observe in the question, we are required to take the most profitable item and the maximum part of it possible to actually land up to the most optimal value. So, this decision making at every step is quite indicative of a greedy approach to be applied to this question. What does a greedy approach tell us? A greedy approach tells us to be greedy at every step, to take the most optimal choice at every step and actually end up to the globally optimal solution. We will apply the same and let's understand the algo for it. So we are going to create an array of items that will be holding the value and the weights together. Now we are going to sort the items in descending order of a standard ratio, value by weight, because both are the deciding factors and we cannot go only by ones because we need an element that holds the maximum value with the least weight. So we would be initializing the two variables for the current weight that we have collected in the knapsack and the total value of those items. For each item in the sorted array, we will traverse over it. If the item fits, like if the item has a weight lesser than the current weight, the capacity weight, then we can add it to our knapsack. We will add it to the knapsack, so both the value and the weight will be added respectively. Elsewise, if the item doesn't fully take up in the knapsack, then we are allowed to take the fraction of it. So we will take unit weight of it and we will multiply it with the remaining capacity, that is the maximum capacity we can take to the knapsack now. So we will add it to the total value. Now we need to break the loop. Why do we need to break the loop? Because if we do not add a break to it, then we will keep on adding more weight to it if the element doesn't fit in the knapsack. That means even though we have reached the capacity, then also we are filling the knapsack, so that's not right. So we have to add a break to it. Then after this we will simply return the total value. So So let's understand the algorithm with the help of an example. Let's get started. So firstly, let's create the items. It will hold value and the weight, so I am creating the items. So we have got all the items made and we have to make an array of it. So we have the item array now. Now we have to sort this items array according to a ratio, the value by weight ratio in descending order, so that we pick up the most profitable element first. So let's write down the value by weight ratio here. So the value is 100 and the weight is 20, so its ratio is 5, it is 6 and it's a 4. Now after sorting the array according to the value by weight ratio in descending order, the array would look something like item 2 will be the first one, then item 1, then item 3. So now the array looks like this. Now what do we have to do? We have to traverse on it and take up the element if it gets in the knapsack wholly, otherwise take the maximum possible part of it. 0, 1, 2, the indexes. So let's initialize the variables so that we have a look what is the current weight and the total value till now. So initially both of them are 0. Let's start with the index 0 and take up the item 2. Now what is the item 2 having the weight? Now item 2 has a weight of 10. Let's write down the capacity here also. Now is the weight of item 2, that is 10, is less than the capacity? Yes, it is less than. So we are able to take that element. So let's add it to the current weight and its value will also be added as we have taken that element. So item 2 has a value of 60. Okay, so we have taken the element as a whole. Now for index 1 we have the item 1. Now let's check the item 1 weight. Item 1 has a weight of 20. Now adding 20 to the current weight will make a 30. Now is 30 less than 50? Yes, it is less than 50. So we can take the item 1 as a whole. Let's add it. So 20 added to 10 is a 30. The item is added as a whole, so the value will be added as a whole, that is 100. 160 make 160. Now we have the item 3rd. So item 3 has a weight of 30. Now is 30 plus the current weight 30, that is a 60, less than 50 the capacity? No, it is not. So we cannot take the element as a whole, but we can surely take a part of it. So how much part can we take? So what is the remaining capacity then we can take from the item 3? So the capacity that has been fulfilled is 30. Now we are left with a 20. 30 is equal to 20. So we can take a 20. So item 3 has a weight of 30. Now 30 weight holds 120 value, then how much value would 20 weight hold? Then 20 weight would hold 120 upon 30 into 20, that would be 80. So we can take 80 value. And how much weight we are taking? That is 20. So 20 becomes 50. 20 plus 30 is 50, and the weight we are taking is 80. So 80 plus 160 is 240. Now as we have taken the element, so we will break out of the loop, as we are done with the capacity. So 240 is our answer, and the output was 240.
As discussed in the dry run, that we are going to have the objects, the items as objects. So there are two ways of creating it. Either we can do it by making a class of the item, or we can use a structure. And as here it is given, so let's uncomment this and use a structure. So we have got an item that is having a value and a weight. Let's start. Let's start by initializing the size of the array, the value dot size. Then we need to create an array of all the objects. So let's create an object, an array of name array and of size n. But what should be the data type of it? As all the elements are of item structure, so the data type would be item, because each element there is of data type item. So now we have a empty array, that is all elements will be filled here. So let's fill it for int I is equal to 0, I less than n, I plus plus, and we will put the corresponding values in the object. Array of I dot value is equal to the value present at the ith index in the value vector. Array of I dot weight is equal to weight of I. Now we have the array filled with all the objects. Now let's sort it. Array comma array plus n. Now this will sort according to ascending order, but we have to sort according to our condition based on that value upon weight ratio. So we have to give a comparator function for it. I'll give you a brief idea of the comparator function who all are not who are not aware of it. So the comparator function needs to be defined, and it's an optional one, because if you don't give it, then it will give you according to the ascending order. It is by default set as less than. That is why we are getting according to ascending order. Now this function this comparator function needs to be it should return a true whenever to that condition that we are wanting it to be sorted according to. So let's do this. As its return type would be true or false, so the return type is bool. So bool, and one more thing, that we need to define it as static so that there is no need of creating a object of it. And it takes two arguments. The one we have to compare them, item A comma item B. Let's compare them. We are going to define them ratios. Both of them are getting will we get a ratio R1 and R2, say. So let's define it. A dot value divided by A dot weight. But you carefully observe that A dot value is an integer and weight is an integer. So when you divide them, it will also give an integer, but that will truncate the value. We will lose our precision. It will be truncated to 1. Then how are we going to compare 1.3? It will also get truncated to 1. So you're getting my point, I hope so. So we need to convert both of them to double. And this value will also come as double. So we are going to do the same for B. So it's R2 and this is B dot value divided by B dot weight. And what do we want? We want to return R1 greater than R2. This will give us the descending order. If you want it in ascending order, you will have to change this sign by less than. Now we have got the sorted array in the descending order. Now what to do? Now we have to check whether the given item is a profitable one to take in the sack and is it being in the capacity. So let's traverse over the array. And we need to keep a track of the value and the weight, then only we can compare whether it has been exceeded the limit or not. And as it is a fractional one, so the current value may not be perfectly in integer, so we cannot lose that also. And as you can see in the example one also, it's not an integer value, it's a double value, so that variable will also be in double. So if the current weight, that is being stored in array of I dot weight, if on adding it to the current weight, if it is in the capacity, then we can surely take it. So it will get added into the current weight. As the item has been added, then it adds to the value as well. But if it is not coming as wholly, then we need to take a part of it. Let's find out what is the remaining part that we can take. Minus the current weight. So we we have got the remaining part that we can try of taking it from the current item. So it will get added into the value. um, how will we calculate the remaining value? It will be calculated by unitary method, that is the value upon weight ratio multiplied by the remaining will give us the value of the remaining. Array of I dot value divided by array of I dot weight multiplied by the remaining. But again observe, it is a division, integer division, and if it will get rounded off, how will we get the correct value of the maximum that we can get from that item? So let's convert this. We are done. We just need to return the value attained. Let's check it. The custom case seems correct. Let's submit this. There seems an error. What is actually happening is that we are exceeding the output because we are overfilling it. We Once we have got the maximum value from the current weight, we should exit from the loop. So let's add a break to it. Let's submit this. Hope it works now. Yes. Thank you so much.